Hello and welcome to Coderific. In this video, we are going to write a deep autoencoder network in Keras. To explain briefly what is autoencoder network, I have placed a picture that I took from this blog, and it explains that autoencoder is a special type of neural network that is trained to copy its input to its output. First, it encodes the image into lower dimension and decodes the lower dimension image back to image of the same size as input. So let's start writing deep autoencoder network in Keras using Keras convolutional layers. I am back to my Spyder editor, and as you can see that I have already imported some of the imported libraries. As I told you before that I'm going to use Keras, and the convolution layers that I am going to use are input, 2D convolution, 2D max pooling, and 2D upsampling. And of course we are going to create a model using Keras.models. First I'm going to write some layers that are included in encoding part, starting from my input layer that has shape of 28 by 28, and it will be a grayscale image. So first layer in my encoding part will be 2D convolution, and the number of output filters are 16, and the kernel size is 3 by 3, and the activation that I've used is ReLU. And I have used the same padding to give the output of the same size as input. In encoding part, every 2D convolution will be followed by 2D max pooling with pool size 2 by 2, and I have kept the padding size same. Now I have written the second block of 2D convolution. This time I have used number of output filters 8, and the kernel size is 3 by 3, which is same as in previous block. 2D convolution is followed by 2D max pooling with the same size of pool, which is 2 by 2. Third block also includes the 2D convolution, and the number of output filters is same, which is 8, with the same size of kernel size. Activation is also same, and I've also used the padding same, and it is followed by 2D max pooling with the same size of pool size. So I have kept my encoding part short, which includes 3 convolution of 2 dimension followed by max pooling. Before I start writing the decoding part, I want to tell you a trick that if you want to get the output of the same size as input at the end of decoding, follow the sequence of encoding layers, walk through these blocks in reverse order, and start from the last convolution with the same parameters of number of output filters and kernel size. So in decoding part, my first layer will be 2D convolution with the same parameter as the last convolution 2D layer in encoding part. Now I am going to replace every max pool with upsampling of 2 dimension. But in decoding, I am going to write upsampling of 2 dimension. In other words, every convolution 2D in decoding part will be followed by upsampling 2D. And the pool size that I am going to use, this is the pool size or the factors by which the output filters will be upsampled, and I have used the same parameters as I used in max pooling in encoding block. Now inside the decoding, I have written second block of 2D convolution followed by upsampling, because I am going in reverse order of encoding layers. So I started with the 2D convolution with the same parameters, and after that, as you can see, the second convolution block is again with the same parameters, which is number of output filters 8 and 3 by 3 pool size. So I have introduced another convolution in decoding similarly followed by upsampling. In encoding part, walking through in reverse order, the last convolution is with parameters number of output filters 16 with pool size 3 by 3. So my next convolution 2D in decoding part will be the same with the same parameters followed by upsampling, keeping the factors same. Now to extract only one feature map or filter map out of these 16 output filters, I am going to write another convolution. So basically I have kept the output as only one filter, and the pool size is same, kept it, but here the activation I have used sigmoid and the padding I have used same. So this is my final layer in decoding that will generate the output filter, which is only single filter, and it will contain the same size as our input. Remember that if I use pool size 2 by 2, the size of output filter will be increased. So the lower the size of pool, larger will be our output filter. So keeping this sequence same as I have written here, we can get 28 by 28 output filter. Now that I have prepared all of my layers, I am going to write a model that will take the input that I have defined in input layer, and the output layer will be the same as I have defined here. After that, I have defined my model. Now I am going to create its summary. So let's run this model. So as you can see in my Python console that I have created my model. If I scroll to the left to make it larger, you can see the shape of model. This is the encoder part that has reduced our input up to the 4x4 8, and from that the decoder part has started with the convolution, which is convolution 3, and as you can see that it has started increasing the size of our output filters convolution by convolution, and finally we have obtained the output image that has same size as our input. This model will take the input of 28 by 28 in grayscale color channel, and it will be trained to predict the image again of the same size as input, which is 28 by 28. This is it for this video. Thank you for watching. I hope you find it helpful. If you did, do like and share. Also subscribe the channel and hit the bell icon so that you get notified whenever I upload a new video. If you have any suggestions, leave them in comments section. I will do consider it. Thank you.